Oh my god, I can't see that. Oh, my dear students, can you see the board? Okay, you can see the board, right? Can you see the electric switches out there? Oh my god, but why I can't see that one thing? Alright, you can see the light, you can see the things written on the board, but can you see the air? Yeah, can we see the air? No, we cannot see the air. Hey guys, welcome back. Welcome to the yet another session of virtual learning, and we're gonna see air and water, and this is gonna be the part 1. So I was talking of air which we can't see, right? Yes, of course, air we can't see, but we can feel the air, right? We can feel the air. Alright, so in this particular chapter we're gonna explore more about air and then about the water. These two things, they are very much important for us, without these two things we cannot survive. They are integral part of our lives today, our lives since the beginning of the human beings or beginning of the organisms. Okay, so air and water. So we're gonna see first about air and then we will head towards the water. So air, what is air? So if I ask you to define air, what will be your definition of air? What is air? We cannot see air, we can feel it, right? Yeah. So what is air? Just think what can be the definition of air? Yes, air is the mixture of several gases. So what is air basically? It is the mixture of several gases. Several means many. The word several means many. So air is nothing but it's the mixture of many gases. The many gases, they are mixed in each other, forming the air that we breathe in. Now what are those several gases? If I have to write the examples or if I have to mention the names of the gases that are mixed into the air, they can be, yes, the foremost important, oxygen. Yeah. Then the one needed for photosynthesis, that is the carbon dioxide. Then what else? Helium. Yes. Hydrogen. Nitrogen. Argon. Many are there. Neon. What shall I write? My God, there are many. Carbon monoxide. Water vapors. Water vapors are the gases? Yes. My dear students, yes, water vapors, they are the gaseous form of the water. We all know that the water is present in 3 forms, 3 states: solid. What do we call to the solid water? Yeah, we call it as ice. The liquid water, the normal water that we drink, and the gaseous water is the water vapor. So air is nothing but mixture of several gases, many gases. Out of that I have mentioned few. What are they? Oxygen, required by all living organisms. Carbon dioxide, required by plants to do photosynthesis. Helium, hydrogen, nitrogen, argon, neon, carbon monoxide, water vapors, etc. I have listed few. Actually, there are many these gases present. Now, when I'm talking of these several gases, what comes into my mind is what is their proportion, what is their amount present into the air, how much amount of nitrogen is present into the air, how much amount of oxygen is present into the air, how much amount of carbon dioxide and the other gases which I have just mentioned here, what is their amount. Because we all know when I'm standing here, I'm surrounded by the air, right? I'm breathing in the air, I'm breathing in all these gases, I'm breathing in all these gases. Out of that, I require only one gas, and that is oxygen, right? And then I'm breathing out, or I'm exhaling the other gases which my body doesn't want. I'm inhaling the air, I'm breathing in, inhaling or taking in air. Out of that, my body filters the oxygen, it takes out the oxygen, and the other gases it is exhaling, it is breathing out, it is giving out. All right, so what is the amount, what is the amount of all these gases, that we're gonna see now in the next point, and that is composition of air. So the next point here is going to be composition of air or the different gases present into air. Now, to understand it in a better way, I'm going to draw one circle. Okay, so I'm going to try to draw one circle. I may not be so perfect with it, but it is going to solve our purpose. Okay, so yes, I have drawn one circle. Okay, so out of that, out of 100%, out of the 100% of the air, 78%, out of the 100%, 78% is the nitrogen gas. 78% of the 78% of the total air is made up of nitrogen. So okay, if we consider this whole circle as 100, if we consider this whole circle as 100, now I'm going to divide it. So this becomes 50-50, right? How much? 78%. Okay, even if I divide this half, it becomes 25, right? So this 50, this 25, it becomes 75, but it is more than that, so I need to consider some this much, okay, approximately. So the entire this particular part here, so this 78% is the nitrogen. 78% is the nitrogen which is present into the air. Now coming to the very essential and the important gas for all living beings, and that is oxygen. So what is the percentage of oxygen present into the air? It's 21%. So what amount of oxygen is present into the air? It's the 21%. So 100 minus 78, it's 22, right? 22. So this particular part is of 22%. Out of that, 21 is the oxygen only. Out of that, I'll take the other chalk, okay? Out of that, 21% is the oxygen. So maybe this pink shaded part, right, it forms the 21%, and that's the oxygen. Okay, now this remaining small portion, the remaining small portion, that's the only 1%, that's the only 1%. This 1%, they are the other gases. So the 1% of the air comprises of other gases. Okay, got it. So this makes the total 100%. So out of the 100% of the air, 78% is the nitrogen. See this yellow portion over here, this major portion of this circle is covered by the nitrogen, which is 78%. Then 21% is the oxygen, and the remaining gases, the other gases, the gases other than nitrogen and oxygen: carbon dioxide, carbon monoxide, helium, hydrogen, argon, neon, water vapors, dust, etc. They are just 1%. They are just 1%. So this is the composition of air. This is the composition of air. Composition means the amount or the different materials that are present into something, so different materials means the different gases which are present into air, that forms the composition of air. So 78% is the nitrogen, 21% is the oxygen, and the 1% is the other gases. Now we all know oxygen. Why is it important? Why is oxygen important? Yes, oxygen is essential or very important for survival of all living things. For every living organism, no matter human beings or the small insects or the bigger animals, they all require oxygen. Yes, even the plants, they also require oxygen. So when it's the dark time or when it's the night time, plants, they are breathing in oxygen, giving out carbon dioxide. In the daytime, the process is completely reversed. The plants are undergoing the process of photosynthesis. That is why they take in the carbon dioxide and give out the oxygen. But in the night, when it is dark and the sunlight is not present, what are they doing? They are actually breathing, and they are breathing in the oxygen. Yes, for all living organisms, oxygen is important. So oxygen is important for survival of all living beings. Also, this oxygen is needed in burning. Okay, it is needed for burning. First, we know that it is required for survival. What is the other important? That it is needed in burning. It is needed in burning fire. It is needed in burning fire. So if you wish to fire something, okay, I have given you some wood, and since it's a winter season, right, it's a winter season and it's very much cold in our surrounding, and we want some warmth. Okay, we want some warmth. So what are we going to do? We're going to have the campfire. Okay, so we'll get some wood. Okay, we'll collect the wood sticks, and then we're going to fire them. We're going to burn them. Now for those wood pieces or those wood to burn, what is required is oxygen. If there is no oxygen, the wood will not catch the fire. The wood will not catch the fire. Yes, even if a small example, if I am giving you one candle, and that candle, if you want to burn it, there has to be the presence of oxygen. There has to be the oxygen present around. If there is no oxygen, then the burning of the candle is not possible. The candle will not burn. So oxygen needed for survival of living organisms, and then it is needed for burning. It is needed for burning. Now coming to the nitrogen. Now you'll say, okay, only 21% of the oxygen is present. Still it is important for burning of fire and for living organisms to remain alive. Now what about nitrogen? You may certainly ask, what is the use of nitrogen? So the nitrogen, it controls the fire. What it does, nitrogen controls the fire. Suppose I am giving you some wooden sticks. Okay, I am giving you some wooden sticks, and now to get the warmth you have set it on fire. Okay, so okay, I said, teacher said that for burning of this wooden sticks, we require oxygen. So you will say, okay, oxygen is present in the air, and I'll fire those wooden sticks. Now what will happen? See, if there is no nitrogen, present into the air, these small fires, even the matchstick, when you strike and we create the fire, they will turn into the big fire. That is why nitrogen is useful in controlling the fire. Okay, it controls the fire. That is how it controls the fire. What it does, it controls the fire. It allows that fire not to convert into the big fire. Okay, so what is the use of it? Nitrogen does not support burning. It is not needed for burning, but it helps in controlling the fire. Okay, so we often see, I don't know whether you guys have heard of this or not. I'll just tell you the knowledge that I have. The rainforests or the Amazon forests, they are burning. They are such a densely they are having dense population of trees that all the time the process of photosynthesis is going on, and they are releasing the they are releasing the oxygen. So what is happening? The oxygen is helping in fire. It is helping in burning. There the nitrogen is in lesser quantity. The nitrogen present there is in lesser quantity. So once the forests, they are on fire, the fire becomes uncontrollable. Because there the amount of oxygen is more than the amount of nitrogen. Is that understood? Okay, so what is the use of nitrogen? Nitrogen, it does not support firing, but what it does, its presence in air keeps the process of burning under control. Even the smaller fires without nitrogen will become uncontrollable. Even if you are striking a matchstick, it will convert into a big fire if there is no nitrogen. So the job of nitrogen present into air is to control the fire. Alright, job of oxygen is to support the burning. And what about the other gases? The other gases, there are many gases are there, like carbon dioxide. It is needed by green plants to prepare their food. Yes. Then there is one gas called as argon, which is of this particular argon. So whatever the tube lights and the bulbs that we have at our house, which keep luminify our house, okay, which keeps our house lit up, what it does, it is used in that. This particular gas, argon is used into the tube lights, electric bulbs, electric tube lights. Okay, it is used. What kind of gas it is? It is a odorless, colorless gas. So this argon is a colorless and odorless gas. Odor means something which is not having smell. not having any peculiar smell. Okay, so argon is a colorless, odorless gas which is present in this other gases in very lesser quantity. It is used in preparing, or it is used in manufacturing of electrical tube lights, bulbs, etc. The carbon dioxide is used by green plants to prepare their food. Hydrogen, helium, water vapor, ozone. Yes, there's this gas, ozone. This gas is also present into the air, and what it does, it traps, it catches the ultraviolet rays, the harmful rays coming from the sun. There are harmful rays which are coming from the sun. This ozone gas, what it does, it catches, it traps those particular rays. So the sun rays which are reaching on the earth, which are reaching to us, they are not causing any kind of harm to us. So I hope you have understood this point in particular. That's the composition of air, or different gases present into the air. 78% nitrogen, 21% oxygen, and the 1% is of the other gases. Okay, now we are going to move to the next point, and we're going to learn about atmosphere. So our next point for today is going to be atmosphere. So this word you already know, sphere. You know what's the shape. So this atmosphere is something which is present in the spherical shape. Okay, so this atmosphere is present into the spherical shape, like how the earth is. What is the shape of the earth? It's the spherical shape of the earth. Earth is in spherical shape. This atmosphere is also in the spherical shape. Now let us first understand the definition of atmosphere, and the definition of atmosphere goes like this: a thick layer of air that surrounds the earth is called okay, it's a thick layer of air. So we often say that there is no atmosphere present on the sun because there is no air present, there is no atmosphere present on the moon. Why? Because there is no air surrounding the moon. There is no air at all. So what I exactly mean by this atmosphere, a thick layer of air, means what I'll show you. Okay, I'm gonna draw at the center. This is gonna be our small earth. Okay, this is going to be the earth. Now what is going to happen? The earth is going to have a thick layer of air. So it is going to have, the earth is going to have a thick layer of air surrounding this. Okay, so the earth is going to have thick layer, a thick layer. Okay, a thick layer. How much thick, that I will tell you, but just try to first understand. Okay, so this the earth is at the middle, and around the earth, on the all sides of the earth, there is a thick layer of air, surrounding the earth. Got it? Yes, because of this air, it is possible for all of us to live on the earth. See, other planets, there are other planets also, right? Other satellites like moon, there are other satellites also. No human beings or no animals are seen on these planets. Why? Because there is no such a air present on the other planets. The earth is the very unique planet. The earth is a very unique planet, that it has got air, it has got water, right? That is why the animals and the plants, they can survive on the earth, because it has got oxygen, right? No other planets have got oxygen, no other planets have got water, no other planets have got air around them, right? Yes, that is the reason the earth is unique, and we all can live on the earth. We cannot live on the moon, we cannot live on this Mars or Jupiter or any other planet. Okay, so this is it. The thick layer of the air that surrounds the earth is called as atmosphere. Now this atmosphere, it is divided into 5 layers. मी इकडे काय लिहिलं यार, layers लिहिले, layers. A thick layer, but this particular thick layer, it is divided into 5 sub layers. It is divided into 5 sub layers. See, this is one layer, then this is going to be the second layer, then this is going to be the third layer, fourth layer, and then the fifth layer. So there are 5 layers of the atmosphere around the earth, or the atmosphere is divided into 5 different layers. The atmosphere is divided into 5 different layers. What are they? Troposphere is the first one. Okay, the first layer near to the earth is the troposphere, then the stratosphere, then is the mesosphere, then is the thermosphere, and then the exosphere. Okay, so 5 layers. There are totally 5 layers. Troposphere, the first layer. Second layer is going to be the stratosphere, mesosphere, thermosphere, and then the exosphere. All right, now we're going to look all these layers in detail now. Okay, so I'm going to rub this definition. You learn this definition. This definition is given in your book. Okay, so please learn it. I may ask you anytime in the online sessions. Okay, now we're going to learn of layers of the atmosphere. Layers of the atmosphere. Now to show you, I'm going to draw half of the earth. Okay, so I'll start from here. So this is going to be the earth, and I'm going to consider like this. Okay, I may not be so particular, but you can make use of your scales while drawing it. Okay, all right. Now the first layer. What's the first layer? The first layer is the troposphere. 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 So it starts from the 0th kilometer. 0 kilometers from the ground of the earth till 12 kilometers. So it starts from 0 to 12 kilometers. In your book, these figures are not given. I'm telling you some extra information, so you can write down in your textbook. Okay, so the troposphere, it's the first layer, and it starts from 0 to 12 kilometers. So as we go 12 kilometers from the surface of the earth up till the 12 kilometers. Okay, from 0 to 12 kilometers, up to 12 kilometers, the first layer that we're gonna see is the troposphere. Okay, maybe I'll consider as this. Okay, so this is gonna be the troposphere. It is going to be the troposphere. Now what it does, it contains the air that we breathe. It contains the air we breathe. It contains the air that we breathe. Okay. Then all the weather changes, they take place into this particular layer. All the weather changes, they take place into this particular layer. Okay. So now we're going to see the second layer, and that is the stratosphere. The second layer, what is the name of that? Stratosphere. Stratosphere. Okay. Now what is the kilometers? 12 to 50 kilometers. So as we go above from the earth, from 0 to 12 we have troposphere. After troposphere, after 12 kilometers, from 12 kilometers till the 50 kilometers, we're gonna have stratosphere. We're gonna have stratosphere. This is from 0 to 12 kilometers, from 12 to 50 kilometers. It is going to have stratosphere. Now it contains ozone layer. It contains the stratosphere. It contains ozone layer. Means it has got ozone gas into it, and it forms a layer. Okay, it forms a layer. That ozone layer is seen into this stratosphere. Now what is the use of this ozone layer? It traps the harmful UV rays. Ozone layer traps harmful UV rays from sun. Now this UV means ultraviolet rays. Now these ultraviolet rays, they are coming from the sun. If they are reaching to us, it can cause some harm. It can cause us some skin diseases. It can burn our skin, right? Yes. So that is why this ozone layer is very much important. So those harmful rays coming from the sun, they will be absorbed by this ozone layer, and that is how it can prevent us from that harm. Understood about the stratosphere? It also has the jet planes flying into this air. All the aeroplanes and the jet planes, they are flying into this particular layer. Understood? That is about the stratosphere. Now moving to the mesosphere. The third type of layer is mesosphere. Then the third layer is going to be mesosphere. So it starts from 50 to and runs up to 80 kilometers. Okay. So once the stratosphere is over, it starts and it is up to 80 kilometers. Maybe like this. Okay, 50 to 80 kilometers. Now what it does, the meteors and the other space stones, they burn into this layer. So what happens? Meteors Understood? What happens into this particular layer? The meteors and the space stones. So I'll tell you what are meteors and space stones. See, we in our solar system we have sun at the center, and all the other planets, they are revolving around the sun. Along with these planets, there are some planets are the spherical in shape. Spherical bodies revolving around the sun, they will be called as planets. But beside these planets, there are some stones. Why I am saying some stones? Like stones, they do not have any specific shape. These other bodies which are revolving around the sun, or they are randomly revolving in the space, they do not have any proper shape. So I am calling those as the space stones. Stones on the earth, they do not have any proper shape. We can see different shapes of the stones. Similarly, space stones, yes, there are certain stones when two heavenly bodies, when two space bodies, they coincide with each other, they strike to each other. Small stones, they are generated, and they are revolving in the space. So it can happen that they are revolving in the space, and they can hit the surface of the earth. Okay, imagine we guys are playing on the school playground, and we see a space stone is coming along our way. What's going to happen, right? What's going to happen? Even as boy from our school, a boy from our class throws a stone, we get scared, we run away. But we cannot predict that the stone is coming from the space. Okay, so it is going to cause harm to us. So in this layer, what happens in this layer? There are some there is presence of atmosphere in such a way that all these space stones and the meteors, they burn there before reaching to earth. So they are not reaching to the earth as they are whole. Okay, stone from the space will not reach the stone from the space. Here entire it is space. Okay, imagine here is the earth, and these are the layers of the atmosphere we are learning, and here is the space. So a space stone coming towards the earth, it will enter into this mesosphere here, and in mesosphere itself it will get burned, and it will not reach to the earth, or even if it is reaching after burning, it is not going to cause any harm to us or to the earth. Remember, we were learning of moon, and then that time we have seen in standard 3 about craters. What are craters? Craters are the big holes on the surface of the moon, big holes on the surface of the moon. Why are they formed? From where are those holes formed? See, there is no atmosphere on the sun, so whatever these space debris or the space stones, they can directly hit the moon. And they are creating the craters. Can we see such craters on the earth? No, we cannot see such craters on the earth. Why? Because there is presence of atmosphere, especially this mesosphere, which is burning all those space stones and the meteors in that particular layer. I hope I am making some sense. If you don't understand, just ask me in the live session so that I can make you understand this concept very well. Now moving to the next moving to the next layer, and that is thermosphere, fourth one. Thermosphere, it runs from 80 to 700 kilometers. So it runs from 80 to 700 kilometers. I need to go a little higher. Okay. All right. So the thermosphere. Temperature here may reach up to 2000 degrees centigrade. The temperature reach up to 2000 degrees centigrade. So thermosphere, as the name suggests, it has got huge temperature, it has got high temperature, it has got a maximum temperature. So thermosphere has got the maximum temperature and it can be up to 2000 degrees centigrade. The space shuttles, they orbit in this layer of the earth. Okay, so space shuttles, they orbit into this layer. Now what are space shuttles? See, we are launching some satellites. We are launching some satellites, which are giving us weather reports, okay, which are giving us the weather conditions. Some they are giving us we are seeing the live cricket matches, you know. So telecommunication satellites. So different types of satellites are there. Artificial satellites which are launched by human beings. There is one natural satellite to earth, that is moon. Okay, so planets, they may have natural satellites and they are called as moons. Then there are artificial satellites which are launched by human beings and they all are orbiting into this particular layer of the atmosphere called as thermosphere. Understood about the thermosphere? Now the last one is the exosphere. The last layer of the atmosphere is going to be the exosphere. Fifth one, what's the 700, see the limit, 700 to 10,000 kilometers. So this particular layer, exosphere, this is the last layer. It is running from 700 to 10,000 kilometers. All right. Okay, so this is going to be the last layer. So the amount of air present into this layer is also very minimum. The least air is present into this layer, least. Okay, so very minimum air is present into this air. Beyond this layer, if we go about 10,000 kilometers from the earth, if we go 10,000 kilometers high from the earth, there won't be any air. Beyond the exosphere, if you cross this, this is the exosphere, if you cross this exosphere, there is no air present into the there is no air present. Okay, beyond this layer there is no air exist. Understood about this? Okay, so this particular diagram shows the layers of the atmosphere. This is the diagrammatic representation of layers of the atmosphere. It is given on page number 126 of your textbook. Okay, it is given there, but these kilometers, they are not mentioned. These kilometers, they are not mentioned on your book. So what you are going to do is, you are going to pause this video right now and take down these kilometers on your book. You are going to take down all these kilometers on your textbook. Is that understood? Okay, now see to it that why this air is forming a layer around the earth. What keeps it binded to the earth? Yes, it's the Earth's gravity. See, the role of the Earth's gravity. The Earth's gravity is holding the layer of atmosphere. It is keeping the air around it. It is keeping the air around the Earth. The Earth's gravity. All right. So we all have continuous flow of air. We all can breathe. We all are surviving because of the air, because the earth has got gravity. So what is gravity? A force which is pulling everything towards the center of the earth. So it is always pulling towards the center of the earth, and that is why this air is maintained around the earth. Understood? So you just go through this video one more time. You read the page number 126. All right, take down all those kilometers, and I'm gonna see you with the importance of atmosphere. Why this atmosphere is needed? What is the use of atmosphere to us, to the environment, sorry, that we're gonna see in the part 2 of air and water. Till then, take care of yourself. All right, my dear students, and I'll see you in the part 2. So till then, bye bye.